Today we're going to talk about the four horses of variables in C. We've already used our dear old friend, the int, for everything so far. It represents a whole number. When you do anything to it, it gives an exact whole number result. Even when we divide it, it'll round down to the nearest whole number. Floats and doubles both hold floating point numbers. This means that instead of storing exact values, it has these two dials that together give an estimate of a number. While these aren't as precise as integers, it lets you have estimates of really big numbers, and most importantly, decimal places. Like how we put int in front of a name to declare an int variable, we can do the same with float and double. So this is a float variable, and this is a double variable. We can do all the basic operations with it, but instead of whole number results, we get approximate numbers with decimal places. We'll notice that when we print it, we're using %LF for a double. If we were using floats, it would be %F for float. But for double, it's LF for long float. Yeah, I know it's inconsistent, but it is what it is. These same format specifiers work with scanf. We can ask for the input weight like this. So then what's the difference between floats and double? Well, when we run the float version, we get a slightly different answer. It's a little bit more wrong in its estimate. That's because doubles are more precise. On our little dials for floats, you can think of doubles as adding double the number of ticks. That gives us more precise estimates for the numbers. Each tick expresses smaller differences. Depending on the number, a float variable can give you about 7 digits of precision, and a double about 15. A lot of the time, this might not make much of a difference, but for larger magnitudes, it can add up. If there's an alien ship hiding opposite the Earth around the sun, and you're trying to calculate the length of their path to go say hi, a float will give you about 6 digits of pi, which means your calculation will be about 14 kilometers off. But you're an astute programmer, so you use double instead. Then you'll be within fractions of a millimeter. Float is less precise than double, and there's mostly no downside to using a double. There might be some cases where you need to use float because you hit some performance issues, but until you hit those cases where you have a real problem first, just stick with doubles. Still, even with doubles, it's still not 100% precise. There's always some small error to the calculations. So when you use doubles or floats, you got to avoid some traps. First, you shouldn't use equals equals directly to check what a number is. That's because depending on the numbers and the order of the calculations, the results will be slightly different. Double equals will say they're not the same because they're technically not. Either you need to check that you've gone past the number you care about, or what you need to do is check how close are these two numbers. By subtracting them from each other, you'll get a number very close to 0 if they're similar values. And then you can check for that. Thing is, the number can be either positive or negative, so to make things easier, we typically wrap it in fabs, which stands for floating point absolute value, which just means it removes the negative sign for us. So we can check if the result of our subtraction is some reasonably small threshold. Also, to use fabs, we need to add this include line to give us access to it. Second, you should consider when you actually need exactness without this error. For things that do, you should still use integers. We use integers to represent money. Otherwise, cents can slip away in calculations. Casting is when you force one type to change to another. Sometimes this is an obvious transition, like if you have an integer 5, it becomes 5 in floating point. But when you go from a float or a double to an integer, it just drops the decimal point. So 4.99999 becomes 4, not 5. A lot of casting happens automatically for you. Like if we assign these double variables to int, it'll just figure this out for you. But other times you need to explicitly ask C to change the types for you. Like here, we have two integers and we divide them. You might expect this to give an answer of 1.5 because we're storing the result as a double. But we only get 1.0. What gives? Well, because both of these are integers, the division is treated as integer division and gives you a 1. Then that gets converted to a double and stored in the variable. To force these to be treated as doubles before they divide, we put double in brackets beside the values we want to convert. Now that these are treated as doubles, we get our expected number. There's some certain rules which C follows about when and where it converts types automatically. I won't go into all of those yet, but it's a good idea to make things explicit and clear by adding the casting yourself, both for C, but also for other people reading your code. By the way, this also applies when you type literal numbers in your code. These are integer numbers, which give an integer result, and these are double numbers, which give a fractional result. If you're following along on codeaesthetic.io, you might consider pausing here and starting the first 3 experiments, and then come back for the next part. Because for the next part, we're going to cover something totally different. Letters and symbols don't really exist in computers. Computers just understand numbers. The letter A is 97, the @ symbol is 64, capital A is 65, and 7, the printable character 7, isn't 7, it's 55. C gives us a basic type to handle these called char. If I create a char variable and put in 97, then print it with the format specifier %C, I'll get a single A. Neat, but remembering all those numbers would be awful. So C can help us out by looking up these numbers for us. If we put the character we want in single quotes, we get the same thing. Note that single quotes are different than the double quotes we use for printf and scanf statements. Double quotes are for strings of characters, and we'll dig into how those work later. Single quotes are for individual characters, which are stored in our char types, basically as a single number that represents the character. We have this rudimentary report card generator here, and we want to augment it to output a letter grade in addition to the percentage. We'll add a character variable for the letter grade and add it to our printf statement. Then add if statements to find out which range we fall into and assign a letter to the grade. I learned while researching this that there's no consistency for these letters across school systems. And in Japan, the top grade is S, which is where those S tier lists come from. I'm going to guess everyone knew that but me. And if we wanted to add in the student's initials to the report card, we can create 2 variables for the initials. One thing that's a bit weird about reading characters is if you scan them in with just the %C, it kind of seems broken. It seems like it just skips over the second scanf for some reason. That's because when you type in the first initial, you're actually typing in 2 characters, the first initial and the special new line character we know from printf when you hit enter. So when scanf is chewing through the characters, the first scanf gets the first initial, and the new line goes into the second, which is why it feels like it skipped over the second line. It didn't, it just read in the second character instead. You can fix this by putting a space in front of the %C inside of the quotes. This tells scanf to ignore any invisible characters and just read in the meat. With this capability, we now have a new superpower. We've been asking the user to enter in 0 or 1 for yes or no questions, but this isn't a great experience. Now we can upgrade our attendee estimator from the last video. When we ask the user if the last concert is sold out, we can ask for the classic Y or N characters. and then we can compare it against a single quoted y. Now our code looks a lot more readable, and our program is more intuitive for the user. Check out the last 3 experiments on codeaesthetic.io for some fun with characters.